All right, in lesson 6.3, we are going to continue building functions from other functions. And in this lesson, we are going to do it by combining functions. And the way we're going to combine them is by adding, subtracting, multiplying, and dividing. So we're going to form new functions by putting together other functions. We're only going to be working with quadratic and linear functions to do this. You could do it with any form, but the algebra gets a little bit more complicated, so we are going to stick with linear and quadratic equations for what we're going to combine. All right, so in the notes here, there are some examples. Let's say you had one function, we'll call it function A, and it is x squared plus 2x. And another function, we can call it function B, that is 7x minus 5. So in this box here, it shows you examples of how you could add those two functions together, how you could subtract those two functions together, how you could multiply those two functions together, and then how you could divide the two functions together. So those examples are there for you to have. We're going to go ahead and do some examples together though. So right here in the middle of the page, we have 4 different functions. We have function A, function B, function C, and function D. And we can pick any 2 of them and combine them using any of those four operations, either addition, subtraction, multiplication, or division. So let's go through these examples though. So starting with example 5, yes, I know these are in a completely random order, but the first example we're going to do is example 5. So we're going to add function A and function C. So let's go ahead and write what those 2 functions are. Function A is x squared plus 2x minus 7. And we're going to add function C, which is x squared plus 4. All right, so to add our 2 functions, it's pretty simple. All we're going to do is find our like terms and put them together. Sometimes I like to keep track of my like terms by boxing my x squares. So I have an x squared and an x squared, so altogether I have 2 x squares. And then how many x terms do I have? I have 2 there. And I'm going to always take my sign with it. I have plus 2x squared there. And then as far as just constants, I have a negative 7 and a positive 4. So when I put those together, I get minus 3. So that is how you add your functions together. You add them and you combine like terms. Let's go to example number 1, right across. So now we're going to subtract example D from example A. So let's start by writing function A again. So x squared plus 2x minus 7. Now we're going to subtract function D. And because we're subtracting, I need to put parentheses around all of D, which is x plus 3. So I'm going to make sure I put parentheses around the whole thing, because this subtraction needs to apply to all of D. We want to subtract all of it. And so one thing to remember is that we are going to distribute this negative to each piece in D. In fact, I'm going to go ahead and do that now. That will be my next step. When you have a subtraction, you want to distribute that negative sign to everything that's being subtracted. So I'll rewrite A, x squared plus 2x minus 7. And then distributing that negative, I have minus x and minus 3. Okay, now I can go ahead and combine my terms. I have 1x squared there, and that's the only one, so I'll go ahead and write that one down. Looking for my x terms, I have 2 there and a negative 1 there, so 2 minus 1 is plus 1, so plus 1x, we'll just write it like that. And then looking for our constant terms, we have negative 7 and negative 3, so altogether that is minus 10. A question you guys have asked in the past, and it applies in this lesson, is what is the difference between a negative number and subtracting a number? And I know on the calculators it makes a difference which button you push. And the reason it makes a difference is because the calculator is trying to guess what you mean sometimes. A negative number, adding a negative number is the same as subtracting a number. However, on the calculator, if you don't tell it that you want to add the negative number, it assumes you want to multiply the negative number. That is why on the calculator it's different. But if I said up here, I'm just going to do a little side example. If I did 4 plus negative 3, that's the same as 4 minus 3. So on your calculator, those two minus signs, you know, the one, maybe a negative sign looks a little different, a little higher and a little shorter, and then the subtraction sign being longer and lower. You can read them different, and on the calculator, they might appear different. On the calculator, if you were to write 4 and then use the little one like that, the calculator would think you meant 4 times negative 3. It would assume you meant that there was a multiplying there, and that's why it's important on the calculator to make sure you're telling the calculator what you think you're telling it. But usually the way we write things, when you write it with a minus, we're assuming you mean adding negative 3. So we're assuming you mean this or this. It's just the calculator that gets confused and sometimes thinks this. So hopefully that little side explanation helped. But subtracting a number is the same as adding a negative number. So if I refer to it as a negative number and you're confused on is it being subtracted or is it negative, it really is the same thing. All right, let's go to example 2. So this is where we're multiplying. So we're going to multiply function b and function d. So function b is negative 2x plus 5. I'm going to put that in parentheses because we're multiplying all of that times function d, which is x plus 3. So when you multiply, put both of your functions in parentheses. Now, hopefully when you look at this, you might have an idea of what we're going to do, but if not, that's okay. We are going to FOIL this, if you know that term, or expand, Santa Claus hat, trick or treat, whatever you want to call it. So we're going to do like this, the negative 2x times the x, and that will give us negative 2x squared. Then we'll take the negative 2x times 3, which will give us negative 6x. Then we'll take our 5 times our x, which will give us positive 5x. And then we will take our 5 times our 3, which will give us plus 15. Now, when you do it in that order, your terms that are going to be similar are going to be these two in the middle right here. And so we put those together and they become, let's see, a negative x, because negative 6 plus positive 5 is negative 1. So we still have negative 2x squared at the beginning. That's all of our x squared terms that we have. And we still have negative 15 at the end. So there is our overall, I'm going to put that in a different color just so it stands out a little bit more. That is our overall answer. I'll circle these ones too. All right. Some of you I know like the box method. I really like the box method. I think it works really well for some of these. So I'm going to go ahead and do this example again. Actually, I'm going to do a different example using the box method. Let's do c of x times d of x. And we're going to use the box method this time. So I'll write above it what it is. So c of x is x squared plus 4. And we're going to multiply that by d of x, which is x plus 3. So remember, when we're multiplying, put both things you're multiplying in parentheses. Now, to do the box method, you need to make your box big enough for how many terms you have. So I have 1 2 terms by 1 2 terms. So that's why I have a 2 by 2 box. All right. So in my box, I'm going to write... Okay, I'm going to write x squared. It doesn't matter which one goes on the top and which one goes on the left. So just pick one to go on the top and one to go on the left. Neither of these has any negatives, but if you had a negative, just make sure you keep the negative sign with the term that it goes with. For example, if it was x minus 3 instead, I'd want to have a negative 3 there. But it's not, so we won't do that. All right, so when you do the box method, just you got to see which 2 terms goes to each box. So for this box here, I got to look at these 2 terms. When I multiply them together, I get x cubed, because x squared times x is x cubed. In my upper right corner, I have 4 times x, so I have 4x. In my lower left corner, I have 3 times x squared, so that gives me 3x squared. And in my lower right corner, I have 3 times 4, so that gives me 12. So then I go ahead and write my terms. I always start with my term that has the highest power So in this case, that is my x cubed term. So I'm going to start by writing that first, x cubed. And then my next highest is my x squared term. I have 3x squared. So I've gotten this one, I've gotten that one. Then I have my plus 4x, and last, plus 12. Okay, so that is how you use the box method. I really like the box method. It helps me stay organized. I don't think it takes that much more space on your paper. So if you don't like doing it, that's fine. But if you like it, I think it's a really good way to keep track of these. All right, last example here is example number 4, and it is dividing. So when we divide, and I'll do this in, yeah, we'll kind of go over here. Okay, when we divide, first of all, let's see, c is x squared plus 4, and then we're dividing d, which is x plus 3. All right, so really all you need to do when you divide is just write the numerator, which in this case is c, so x squared plus 4, over the divisor. All right, x plus 3. So you just write it like that and you are done. If you could simplify it, if there was anything that you could factor out of the top and also factor out of the bottom and reduce, but usually you can't, and so you just end up leaving it like that. When you get to 11th grade math, you're going to work with dividing polynomials a lot more, and there's a few more steps you can do, a few more things you can do. But for now, you're just going to leave it like this in this form. All right, so those are the examples. That is most of what the homework is. Taking a quick look at the homework, there are 6 different functions, f, g, h, k, m, and n, and then problems 1 through 7. They want you to combine them in different ways. And so that will be the first part of your homework. The second part of your homework is a word problem. And so we're going to go back to the notes, and I have a word problem example. It's a little different, but hopefully it will help you with the word problem. This word problem may look familiar. It is the word problem from homework 5.4 that I told you not to worry about, that we weren't going to do. So we are going to do it today. So it's an example of why you might combine functions. So let's see. A company is hired to put a sidewalk around a parking lot. The parking lot is 50 feet by 80 feet rectangular. So just looking at our picture, 50 feet by 80 feet, and then they want to put a sidewalk all the way around. So there's the sidewalk. The sidewalk can be any width, so that's why it's x, because we don't know how wide it is, as long as it's the same width all the way around. So it's going to be x all the way around. All right. So we've looked at the figure. That makes sense. So what they want us to do is write a model for the area of the combined parking lot and sidewalk. So the combined parking lot and sidewalk is they want this total area, the entire area. They want to know how big that area is. All right, so area is length times width. All right, so first of all, we don't know what our length is and we don't know what our width is. So we have to actually write those equations first. So let's look. Our length right here, our length is going to be x and then 80 and x. To get all the way across, it's x plus 80 plus x. So we could rewrite that combining terms as 2x plus 80. So our length equals 2x plus 80. And then our width is similar. We have x at the top, x at the bottom, and in the middle we have 50. So it's going to be, our width is going to equal 50 plus 2x, or I guess I could have said 2x plus 50. So our width equals 2x plus 50. All right. So our area is actually combining two functions. We have the function for our length, which is 2x plus 80, and the function for our width, which is 2x plus 50. If I wanted to, and I'm going to do this just because, I could write these as functions of x because they are functions of x. Length is a function of x, and the width is a function of x because that means they're dependent on x. And so the area is going to be a combination of those two functions, multiplying the length function by the width function. So to multiply those two together, we're going to just do just that. 2x plus 80 times 2x plus 50. Now I know I said the box doesn't take up a ton of space, but it does take up some space and I don't really have room for it. So I'm going to do the Santa Claus hat or the trick-or-treating or foiling. So 2x times 2x is going to equal 4x squared, and then 2x times 50 is going to be 100x. 80 times 2x is 160x, and then 80 times 50, 8 times 5 is 40, and then I have 2 more zeros, so 4,000. So there's my equation. I just have a couple like terms here. I could combine those two like terms. So all together I have 4x squared plus 260x plus 4,000. So that is the equation for my area. So that is an example of why you might combine functions by multiplying. Part B says write a model for the area of the sidewalk only. So now we want just the sidewalk. So the sidewalk is going to be the total area and then subtracting this part in the middle. And so to subtract the part in the middle, what is the area for the part in the middle? The parking lot. Well, let's get a different color here. The parking lot area, which we could call P of x, except it's not a function of x because it's just a constant function, because it's just a number. The parking lot area equals 80 times 50 because we know how big the parking lot is. It just equals 4,000 square feet. And so if we subtract the area to get the sidewalk area, it's just going to equal the total area minus the parking lot area. So it's going to equal this function here minus 4,000. So it will equal 4x squared plus 260x plus 4,000 minus 4,000. They cancel out. So that is our total area of the sidewalk right there. All right, and the last question, how many square feet of concrete will be needed if the company decides to make the width 5 feet? So remember, the width of the sidewalk is our x, and so they're saying what happens if we decide to make x equal to 5? So what they're saying is when x equals 5. So in other words, what is the sidewalk area when x equals 5? Well, remember that the equation for the sidewalk area was this right there, so we're just going to plug 5 into that. So 5 squared plus 260 times 5. All right, so 5 squared is 25, so 4 times 25 plus 260 times 5 is going to be 1,300, and then 4 times 25 is 100, so 100 plus 1,300 equals 1,400. It's a word problem, so let's answer in units square feet. So that's how many square feet of concrete they need. All right, so that's an example of a word problem. The word problem on your homework is not quite as difficult. They give you the equations that you need to put together, and then you'll have to use that information to find something useful with it. So good luck on the homework, and we'll see you in class.